All right, so welcome back. In a normal lecture, this would be about to start. So you would have gone through all the videos, you would have gone through all the quiz, and maybe even the lecture notes that we're having, and then we're coming back to this session. We're going together through the quiz, and we'll also recap some of the questions that were on Piazza. Now this time, nobody has really asked something. So let's move on. First part that was discussed was parameterization and parameterizations of position in particular. The reason for that is not really that I would like you to do a lot of stuff with parameterizations of position, but it's really about making sure that you understand the difference between what is a position and a parameterization, because we really have to have this understanding later when we're talking about rotation. So people start adding up Euler angles and think they add rotations and stuff like that. And I think we have to make you aware here first with a very simple example in positions, then move on with rotations later. So what we had to do here is take this very first vector here, 1, 0, 0, and write it up in these different ways of parameterization. So this is obviously this vector going along the x-axis here. If I take my position, if I take this vector, I have a 1 in x, 0, and 0. So obviously the first Cartesian coordinates are the same as the position vector itself. If I look at cylindrical coordinates, I'm going to have rho equals to 1. I'm going to have this theta angle, which is 0. So I have a 0 here. And I have a c height, which is also 0. So by accident here, this is the same, but it doesn't have to be, of course. And if you do the same thing, then also for spherical coordinates, for this vector, we see that this angle is 0, r has length 1, and then that angle theta here, phi here, has pi half. So it's 90 degrees going down. And you do the same thing then also for the second vector, which is in the plane yc here in the back. And also there, Cartesian coordinates are the same. If you look at the cylindrical coordinates, we're going to have rho equals to 1. We have theta, so that angle here, because you're in the back plane, is 90 degrees. And then we have the height, which is also 1. And do the same thing also for the spherical. And then you do this for the 1, 1, 1 vector. I mean, it's just an example for you to show if we add up parameterizations, this is generally wrong, except if you have Cartesian coordinates. So never do this for other representations. And I hope this is a learning for you for the next step when we move on with rotations. All right. So if I don't see questions in the live chat or on Piazza, I will just move on. Also, people can raise hands or start speaking if they want. The third part was an introduction to rotations and then transformations. The fact we're bringing here transformations simply because many people use it often for a compact way of writing. If you have to write things up very often, it's much easier to just look at offsets and rotations, but you can make it more complex if you write it as transformations, but it's nothing else than that, than a rotation and an offset. So first step was finding the transformation matrix. So this top left 3 by 3 matrix is the rotation matrix. So what do we have here? If I look at the frames A and B, I see that my B frame is rotated along the x-axis by 90 degrees, right? Now, either I go back to my elementary rotations, I have this formula somewhere and I read out, okay, I have 90 degrees rotation around the x-axis, I fill in my sine and cosine and I end up with that. Or I say, okay, this, my first element here is the x-axis of the B frame expressed in A frame. So this one expressed in that frame. Obviously, this is 1, 0, 0. Second one is y-axis of B frame expressed in A frame. So I have this vector here of B frame expressed in A frame. And that one has obviously a 1 along the C-axis of A frame. So it's 0, 0, 1. And then the last one, this one, points negative in C, so it's a -1, points negative in Y, so it's a -1 here. So that's for the rotation matrix. Then what we have here on the top right is the offset, which is given already. So RAB in A. And then if you have to find the vector, all you have to do is you just multiply this with this 0, 1, 1. This is 0, 1, 1 vector here, and filled up with a 1, and you end up with your rotated and shifted position vector RAP in NA. Now, this is only a very simple example. Typically, you have a huge articulated structure, like with a couple of segments, one after the other, and you want to figure out what is my end effector in my base frame as a function of the individual rotations of these joints. And this is essentially nothing else than a lot of consecutive transformations. We're going to see this in the next session, or in 2 weeks, actually. Also here, no question. And then the last one is actually just a very quick and simple one. I give you a rotation matrix, how B is rotated with respect to A, and that changes over time. So obviously, if the rotation changes over time, there must be an angular velocity that describes the rotation of B with respect to A. To get omega, all we need to do is we take this formula that we looked at, the cross product matrix omega AB A is C dot times C transposed. So we take this matrix, we take time derivative.
Taking really quickly, I took some notes about the concept of operation, the drawing you did first, but then I figured that the diagram you were making was better than writing it all out on a Word document.
Sorry, I couldn't understand it. Was this question now, or? Okay, maybe it was not related to what we're talking about here. Anyway, so you take here, second one is the transposed of it, you multiply, and you end up with this matrix here on the bottom. And what you need to do now is you have to go to your notes or to the slides that you've seen before in the video or in the script, and you check what is the cross product matrix of a vector. And you see that here we have the minus X entry, and here we have the X entry, and here we have the minus X entry. So if I have omega, I get the minus alpha dot in X direction. And that's it. So these are the quick quiz for this week. It was really nothing challenging. I hope this was straightforward.
Yes, same for me. I mentioned that on the Slack for the kickoff beers, but I'm currently in quarantine, so I can't. I can only be here starting on.
Okay. So for most of you, hopefully this was just a pure recap, nothing new. We're gonna start with like more in-depth stuff coming next week.